So, let's go. Every photograph, every documentary, every textbook. The moon is gray. Every single astronaut who walked on it or orbited it between 1969 and 1972 said the same thing. Gray dust, gray hills, gray everything. Gene Cernan, the last human to walk on the moon, put it simply. The moon is bland in color. I call it shades of gray. On April 6, 2026, 4 astronauts flew past the moon and saw green. Here's everything the Artemis 2 crew reported that contradicts what Apollo found. Number 1. The gray moon is a lie. Kind of. Gene Cernan wasn't wrong. He was standing in gray dust. It coated his boots, his gloves, his visor. It got into everything. It smelled like gunpowder and stuck to every surface it touched. Every Apollo astronaut who walked on the lunar surface was surrounded by the same gray regolith, and they all reported the same thing because they were all doing the same thing, standing in one spot on one part of one hemisphere, looking at what was directly in front of their boots. That's like judging the entire geology of Earth by staring at a parking lot. Here's what the Apollo astronauts couldn't do. They couldn't step back. There was no step back. You're either on the moon or you're not. When you're on the surface, you see the surface. When you're in orbit at 70 miles up, you see a narrow strip of terrain scrolling past beneath you. You see the texture of one region and then another region, and then you're on the dark side, and then you come back around and do it again. You never see the whole thing. You never see the moon the way you can see a painting when you walk to the other side of the gallery and let your eyes take in all of it at once. All of it at Mission specialist Jeremy Hansen, flying at 4,067 miles above the surface, saw the whole painting. Near Aristarchus crater on the near side, he described greenish hues unlike anything visible anywhere else on that hemisphere. A massive brown region on the far side shaped, he said, like a piece of pie, with the point aimed directly at Orientale Basin and the wide end sweeping up toward the northern edge of Hertzsprung. More brown in the northwest highlands. More near Glushko crater, not one color, not one region. A patchwork. A geological portrait of a world that has been hit, melted, excavated, and resurfaced over 4 billion years. The green is most likely olivine, a deep mantle mineral, the same one that forms the gemstone peridot, that gets dragged to the surface when a massive impact punches deep enough to pull material from miles underground. The brown is iron in the rocks, common in the ancient basalt plains called mare. These aren't random colors. They're a map. They're the moon pointing at itself and saying, here is where I was hit hardest. Here's what I'm made of underneath the layer you've been looking at this whole time. NASA's own scientists noted before the mission that human eyes are more sensitive to subtle color variation than any camera currently in lunar orbit. The Lunar Reconnaissance Orbiter has been circling the moon since 2009, building the most detailed maps we've ever had. And it still missed what 4 pairs of human eyes caught in an afternoon. Now, and this matters, the color findings are real. Crew reported and NASA confirmed, but the full scientific analysis hasn't been published yet. What scientists think the colors mean is the leading interpretation, not the settled conclusion. What the crew saw isn't in question. What it proves is still being worked out. But consider the comparison. Apollo 17, December 11th, 1972. Harrison Schmitt is walking near a crater called Shorty when he stops mid-sentence. Wait a minute. I see orange soil. One crater, one discovery. The entire Apollo program's most significant color observation in a patch of ground a few feet across. It took decades of analysis to understand that the orange was tiny glass spherules produced by explosive volcanic eruptions 3.6 billion years ago, and that discovery alone rewrote what we thought we knew about the moon's volcanic history. That was it. That was the color moment for the whole Apollo era. One spot. 50 years to make sense of it. Artemis 2 saw regional color variation across an entire hemisphere in 7 hours. The orange told us the moon had a violent volcanic past. The green and brown may tell us where that volcanism spread, how deep it reached, and what the interior of the moon actually looks like. One observation was a single pixel. The other was the whole image. The moon didn't change. The angle did. Number 2, the moon is getting hit constantly right now. The moon has no atmosphere, not thin, not weak, zero. Nothing between whatever is flying through space and the surface. So when a rock, a pebble, a fist-sized chunk, a centimeter of iron and silicate traveling at 40,000 miles per hour, crosses paths with the moon, there is no friction, no burning up, no slowing down. It just hits. The kinetic energy converts instantly into heat and pressure and light. A flash of plasma that exists for less time than it takes to blink, visible for a millisecond against the darkness before the surface goes quiet again like nothing happened. Commander Reed Wiseman was watching when one happened. Then another. He radioed mission control in real time. That was definitely impact flashes on the moon. And Jeremy just saw another one. The flashes lasted, in his words, a millisecond, like the fastest a camera shutter can open and close. White to bluish white. That color matters. Blue-white plasma means the temperature at the impact point was extreme enough to ionize the vaporized material, both the impactor and the surface rock turning simultaneously into superheated gas that radiates light as it expands. You're not seeing a fire. You're seeing the brief, violent birth of new crater. The crew confirmed at least 4 of these during the observation window. NASA's official post-mission count is 6. In the entire Apollo program, across every crewed mission, every orbital pass, every astronaut who looked out a window at the lunar surface between 1969 and 1972. There were approximately 3 reported impact flashes total. The Artemis II crew equaled and likely doubled that number in a single afternoon. Mission Control lost it. The science lead described audible screams of delight from the room. She later said she wasn't sure she expected the crew to see any at all, which is the kind of thing a scientist says when the universe decides to be generous on a specific Tuesday. The reason they could see them comes down to geometry. To spot a flash of light against the lunar surface, you need the surface to be dark, and the near side of the moon, the Earth-facing hemisphere where the flashes occurred, was dark because of the solar eclipse, which you'll get to in a few minutes. The eclipse didn't just create a beautiful view, it created the observational conditions that made this discovery possible. These things are connected in ways that only become clear after you've seen them all. Now here's the part that stops being just exciting and starts being a little unsettling. The impact flux on the moon, how frequently objects are hitting it, feeds directly into the hazard assessments for every future structure, every habitat, every base humanity is planning to build there. If the rate is higher than current models assume, you want to know that before you pour the foundation. One scientist with decades of studying lunar impacts put it plainly. The observations raise questions about whether the daily flux of meteors is being monitored closely enough before a lunar base gets established. The Artemis II data isn't just historical, it's engineering input for what comes next. You thought the moon was a quiet, finished place. It's a target range that never stopped running. Number 3, being closer was actually worse. The entire logic of Apollo was proximity. Get there, land on it, touch it, stand on it. That logic is correct for surface geology, for sample collection, for EVAs, for understanding what the ground is made of in one specific place. For those things, you cannot be too close. But for understanding the moon as a world, as a complete geological object with a history written across its entire surface, proximity was the worst possible position to observe from. And nobody fully appreciated that until Artemis II sat 4,000 miles back and looked at the whole thing at once. At 70 miles altitude, the Apollo command modules saw a strip, a corridor, terrain passing beneath them at orbital speed, never more than a few degrees of arc visible at any moment. The full disk was geometrically impossible. The poles were unreachable from the low equatorial orbits Apollo used. The far side appeared only in darkness. Whatever regional patterns existed across the surface, color, brightness, texture, the boundaries where ancient lava flows met highland terrain, all of it blurred into local detail with no continental context. At 4,067 miles, the Artemis II crew could see 14.6 million square miles of lunar surface simultaneously. The whole visible hemisphere all at once as a single coherent object. Pilot Victor Glover described watching the Terminator, the line where a lunar day bleeds into lunar night, and said something that exists in no Apollo transcript from any mission. What it does to the features of the moon, to the terrain. There's just so much magic in the Terminator, the islands of light, the valleys that look like black holes, where you'd fall straight to the center of the moon if you stepped in some of those. Nobody had said that before because nobody had seen it from there before. The Terminator from low orbit is a line you cross. From 4,000 miles, it's a landscape. It has texture. It has drama. It looks like something. Christina Koch noted the startling brightness of fresh craters against the dark landscape. Fresh on the moon means geologically recent, which can mean anywhere from a few thousand to a few million years old. Those craters are bright because the impact punched through the surface layer that solar wind has been slowly darkening for billions of years and exposed the cleaner material underneath. From the ground, you'd never notice the contrast because you'd be standing in one or the other. From 4,000 miles up, it pops like a lamp in a dark room. The crew also observed Reiner Gamma, a mysterious bright swirl on the near side whose origins scientists are still actively debating. It's not a crater. It has no topographic expression, no raised rim, nothing to explain why it's brighter than everything around it. The leading theory involves a magnetic anomaly in the crust deflecting the solar wind that would otherwise weather and darken the surface. An alternative involves a cometary impact that compressed and mixed the regolith. Nobody has settled it. The Artemis II crew observed it directly and contributed imagery to an open scientific question that has been open for decades. All 6 Apollo landings combined covered roughly 14.5 square miles of surface traversed on foot. Artemis II observed approximately 1 million times more surface in a single 7-hour session. Not the same kind of science. You can't pick up a sample from 4,000 miles away, but a completely different category of knowing. Apollo gave us depth in a handful of locations. Artemis II gave us breadth across a hemisphere. You need both. We had one for 50 years. The closer you are, the less you can see. That's true for paintings. It's true for people. Turns out it's true for moons too. Number 4. 4 billion years of far side, first human eyes. The moon is tidally locked. One rotation per orbit, the same face always toward Earth, the other face permanently turned away. We didn't know what the far side looked like until a Soviet probe sent back blurry photographs in 1959. We didn't have detailed maps until 2009. And here's the detail that gets quietly buried in most coverage of this mission. Every single Apollo crew that flew around the moon crossed the far side in complete darkness. They went behind the moon, lost radio contact with the Earth, came back out the other side. Whatever was on that face was invisible to them. Every photograph of the far side in the history of human spaceflight before April 6th, 2026, was taken by a machine. The Artemis II trajectory was timed specifically so the far side was illuminated when the crew reached it. Victor Glover looked at the sunlit far side of the moon for the first time any human ever had, and said, "Not the moon I'm used to seeing." What they saw included Hertzsprung Basin, a 400-mile-wide ancient scar, heavily eroded by billions of years of subsequent bombardment, its original structure barely legible beneath the accumulated damage of geological time. And at the southern edge of their view, the thing that made every lunar scientist lean forward, the South Pole Aitken Basin. 1,550 miles across, 6 miles deep on average, 4.2 billion years old. The largest and oldest confirmed impact basin on the moon, and one of the most scientifically important structures in the entire solar system. Whatever hit the moon hard enough to create it, and something did, something enormous, something we have no direct record of. The impact was so violent it may have punched straight through the crust and into the mantle. The basin is a window into the moon's interior, an excavation so deep and old that the material exposed at its floor could tell us things about the early solar system that no other structure on Earth or moon can provide. 4.2 billion years old means it formed 600 million years before complex life appeared on Earth. The dinosaurs hadn't happened yet. The continents hadn't assembled yet. Whatever hit the moon to create that scar did so in a solar system that would be unrecognizable to us. And the Artemis II crew were the first humans to look at it with their own eyes, from a spacecraft named Integrity, 40 minutes after losing contact with every other human being alive while eating maple cream cookies that Jeremy Hansen brought from Canada. Both things are true. The universe doesn't do solemnity on command. The South Pole Aitken Basin is also where the next crewed lunar landing is planned. The Artemis 2 crew was looking at their successor's destination, looking at it from the only angle that shows its true scale. You can imagine what that felt like. You can imagine the weight of it, but you can't really know unless you were there, floating in the dark, watching the oldest star in the solar system slide past your window, while Earth sat silent behind 400,000 miles of vacuum. Number 5. The Grand Canyon of the Moon, seen whole for the first time. Oriental Basin is 3.8 billion years old, roughly 580 miles across. The youngest large impact crater on the Moon and the best preserved multi-ring impact basin in the entire inner solar system. When the impactor hit, the Moon couldn't contain the energy in a single crater wall. The ground rippled. 3 concentric rings of mountains formed concentrically outward from the impact point, each one marking how far the shockwave traveled before the rock refroze around it. Think of dropping a heavy stone into thick mud and watching the rings spread outward and harden in place, frozen at the moment of maximum displacement. That's Orientale. Those rings are still there. They will be there long after everything built by human hands has turned to dust. Apollo could only see the eastern edge. Robotic probes mapped it from orbit over decades. But the full bullseye, the complete 3-ring structure, had never been seen whole by a human being until Commander Wiseman described it in real time, from 4,000 miles out, in words that were both casual and precise in the way that only genuine observation produces. The annular ring, which I think everybody describes as a pair of lips or a kiss on the far side of the Moon, from here is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking. Far more circular than I remember it looking in our training. That asymmetry he noticed, darker, north, lighter, south, isn't just a visual detail. Darker means basalt, ancient volcanic fill that pooled in the lower sections of the basin after the impact. Lighter means highland terrain, older and less processed. He was reading the geological history of a 3.8 billion-year-old impact scar with his naked eye from a moving spacecraft while traveling 2,000 miles per hour, and he described it accurately on the first pass. Near Oriental, they spotted 2 small, unnamed craters. The crew proposed names. The first, Integrity, for the spacecraft. The second, Carol, for Carol Taylor Wiseman, Reed Wiseman's wife. A neonatal intensive care nurse who spent her career keeping the smallest, most fragile human beings alive. She died of cancer in 2020, 2 years before her husband was assigned to command the first crewed lunar mission in half a century, 6 years before he flew it. 252,000 miles from Earth on the far side of the Moon, in the shadow of the oldest impact basin humans had ever looked at directly, all 4 astronauts embraced. Mission Control in Houston held a moment of silence. The names need formal approval from the International Astronomical Union. The paperwork hasn't cleared. But the moment is already permanent in a way that no bureaucratic process can touch. The craters exist, the names were spoken, the tears happened in deep space. Whatever the IAU decides, Carol Wiseman's name has been said out loud on the far side of the Moon, and that is not something that unhappens. Oriental Basin is roughly the size of Texas and New Mexico combined. It is 3.8 billion years old. The first humans to see it whole named a piece of it for a woman who never made it to the launch. Number 6, the eclipse nobody had ever witnessed. You know what a solar eclipse looks like from Earth. The Moon slides between you and the sun. The sky goes dark in the middle of the day. The corona appears, that faint wispy ring of plasma around the sun's edge that's normally invisible because the sun itself is too bright. Stars come out, animals go quiet. It lasts a few minutes and then it's over and the world comes back. Now take everything you know about that experience and put yourself on the other side of the Moon. As Orion emerged from the 40-minute communications blackout, which you'll get to in a moment, the geometry aligned. The Moon sat directly between the spacecraft and the sun. The crew watched the sun disappear behind the lunar disk. Not a partial disappearance. Full totality. 57 minutes of it. The solar corona wrapped around the edge of the Moon in every direction, not a sliver of it like you might catch at the edge of an eclipse from Earth, but the full halo, symmetrical and vast, extending millions of miles into space in every direction. Venus was visible. Mars was visible. Saturn and Mercury were both visible at the same time, in a sky that should have been daylight but wasn't, because the Moon had swallowed the sun whole. Victor Glover looked at Earth's night side and reported that the Earthshine, light reflected off Earth's surface bouncing back onto the moon, was far brighter than expected. Bright enough to make out terrain features on the darkened lunar surface. Earth is about 4 times the angular diameter of the moon as seen from the lunar surface, and it reflects far more light. From this position, Earth was essentially a lamp illuminating the moon's dark face from across 400,000 miles of space, and the impact flashes from earlier. They were visible during this window too. The eclipse provided the darkness that made them detectable. None of it was accidental. The science team planned for this geometry precisely because they knew the eclipse would create the observational conditions that the flyby needed. The eclipse, the flashes, the corona, the Earthshine, they were all part of the same 70-minute window, overlapping and amplifying each other in ways that only come together once, in one place, at one specific alignment. Wiseman told Mission Control, "There are no adjectives to describe what we're seeing out our window right now." Glover called it science fiction. No Apollo astronaut ever experienced this geometry. The alignment only exists from the far side of the moon's shadow at this specific position in space. The crew put on eclipse glasses for the partial phase, watched the sun's disk disappear piece by piece, then remove them when totality hit, and watched the corona with their bare eyes for nearly an hour. An hour of watching the sun's outer atmosphere glow around the edge of another world while stars appeared around them and Earth shone like a lantern in the dark. No human before April 6th, 2026 had ever done that. No human before that date had ever been in that place at that moment. The universe had been running that eclipse geometry for billions of years. It just didn't have anyone in position to watch it until now. Number 7. The record nobody wanted to own. April 13th, 1970. Apollo 13 is 56 hours into its flight when an oxygen tank in the service module fails. The explosion vents oxygen and power. The spacecraft is crippled. The crew, Jim Lovell, Jack Swigert, Fred Hayes, cannot land on the moon. They also cannot turn around and burn directly for Earth because they don't have enough power for that maneuver. The only survivable option is to let the moon's gravity do the work, swing them around the far side, bend their trajectory, and slingshot them back toward Earth on what's called a free return trajectory. That path took them farther from Earth than any crewed mission had ever gone. 248,655 miles. A distance record set, not because anyone was trying to set it, but because a catastrophe left them no other choice. They were the farthest humans from Earth in history, and they were doing everything they could just to stay alive long enough to get back. That record stood for 56 years. It stood because no subsequent mission had any reason to fly that trajectory. Nobody needed to go that far. Nobody planned to. Until Artemis 2, which used almost the same free return path, not because of an emergency, but because it was the correct trajectory for the mission. At 1:57 in the afternoon, Eastern Time on April 6, 2026, Artemis 2 passed 252,756 miles from Earth. 4,101 miles beyond what Apollo 13 managed while its crew was rationing power and trying not to freeze to death. Jeremy Hansen speaking at the exact moment the record broke. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived. And on this mission, on this specific spacecraft crossing this specific distance, the first woman to travel beyond low Earth orbit, the first person of color to travel around the moon, the first non-American citizen to travel around the moon, the most people in deep space simultaneously in all of human history. 4. Breaking the record of 3 that Apollo 8 set in December of 1968. Apollo 13's record was a scar. An accident made permanent by mathematics and desperation. Artemis 2's record was a choice. A trajectory selected deliberately, flown intentionally, by a crew assembled to represent something specific about who gets to go next. The distance is almost the same. What it meant could not be more different. The moon hasn't changed. It has been sitting there for 4.5 billion years. The same gray surface, the same craters, the same far side permanently turned away from every human eye that ever looked up at it. Nothing about it changed on April 6, 2026. What changed is where we stood. 4,000 miles back instead of 70. Eyes trained specifically to notice color instead of focused on landing procedures. A trajectory timed to an eclipse that darkened the near side and revealed the far side in sunlight for the first time in human history. A crew that included, for the first time, everyone who was previously told this wasn't for them. Apollo told us what the moon looked like from the ground. Artemis 2 told us what it actually is. A geologically complex world with color and history and an impact rate that should make future base architects nervous, and a far side that has been waiting 4 billion years for someone to finally look at it properly. In 2028, if the schedule holds, someone is going to stand near that South Pole. They'll look up and see Earth as a small blue marble, distant and fragile in a black sky. They'll feel the gray dust under their boots. They'll report gray. They won't be wrong, they just won't be seeing the whole thing. Nobody on the surface ever does.